So let's do a review problem of each of the kinds of inequalities that we did yesterday. Okay, so do you remember what those were? Remember what they look like? Just general style? Oh my. We had some with absolute value in them. Right?
Yes.
And I don't care how you do this, but the way I'm going to do them all the time is on a number line. And I'm going to start by putting a number right in the middle of the number line. What number am I going to put there? -4. I'm going to put the opposite of whatever's in the parentheses. That is my starting point. All right? Then I look at this number, and I start right here at my starting point, and what do?
Go up to.
I go 2 units this way and put a dot, and then I go 2 units this way and put a dot. In this case, I color the dots in, right? And then I shade. I mean, it's that simple. So I got to decide, am I going to shade out or am I going to shade in between? Which is it? Out. Greater than is out. So out we go. And then we can write our answer either, depending on directions. If there are no directions, it doesn't matter. All the x's less than or equal to -6, or greater than or equal to -2, less than -6, greater than -2. Or we could write it as an interval, but if we're going to write this as an interval, we're going to use infinities, right? So from -infinity to -6, or from -2 to positive infinity.
Why did they go opposite ways again?
Because it's greater than. That distance has to be more than 2 units away. We want to be farther away than 2. Okay? And then the other kind of inequality we looked at
The X.
is one that had a power in it. So something like, cheat a little bit here. How about 2x squared plus 5x is less than or equal to 3. Now, I put this one up here because if you looked at your homework, some of them look like this in the homework, and none of the ones we did yesterday looked like this. What was always over here yesterday?
0.
A 0. You need to have a 0. So it's real easy. Just rearrange things so you have a 0 over there. So we got 2x squared plus 5x minus 3. Now I promised you any one of these that I give you will factor, because that's what I need to do. I need to factor, because the factors are going to tell me where to put the dots on my number line, right? So anybody see how this one factors? It's going to have to be a 2x and an x, right? Because I got to get 2x squared.
It's going to be, you have 3 plus 3 on that side.
I have a 3 out here, a plus 3 here, and a minus 1 here. Now, I think he's right, but I'm going to double check it, because I really want you to get in the habit of double checking these harder ones, unless you're really, really sure. Because if you mess up the factors, if you get the wrong factors, guess what's going to happen to your dots? They're going to be wrong, which means your answer is going to be wrong. So we want to make sure our factors are right. So I'm going to FOIL this out. 2x squared plus 6x minus 1x minus 3. Does that give me my problem? Does that add up to my problem? Yep. So these are the right factors right here. That tells me I'm going to have 2 dots on my number line, and they will be solid dots. And where will those dots be? Now they're going to come from our factors.
1/2.
So one of them will be a positive 1/2. Right? Think about it. 2x minus 1 equals 0. If you solve that, you get 1/2, right? And the other one will be at -3. Now, do I know how to figure out where to shade this?
You got to plug it in.
Pick a number. And it doesn't matter what number. That's the beauty of the thing.
1.
Any number we want, we're going to pick. So if you pick the number 1, keep in mind it's out here. That's the number that you're checking, the one that's out there. If you put 1 in, put 1 in for x. That parentheses would be 1, and that one would be 4. If you multiply 1 times 4, are you less than 0?
No.
No, which means the area that you checked does not work. So if I don't shade that one, then I'm going to shade this one,
Yes.
and I don't shade that one because they alternate. Now, you, right from the beginning, were saying in here, because in problems like this, when there's only 2 dots, the same rule we learned over here, greater than is out, less than is in, applies here. Same rule applies if you only have 2 dots. Do you remember some problems we looked at yesterday there that had more than 2 dots?
Yeah. You had to.
So you really have to check those. Yeah, you really have to check those. So my answer, I'll write this one in an interval because these are so easy to write as intervals, would be bracketed from -3 to 1/2. Okay, that's a little review of what we did yesterday. Okay, so we're going to finish the material today. So let me just give you a little rundown. Homework is due Monday. I think I already told you that, but I'm telling you again. Homework is due Monday. Now let's talk about that for a second. Whenever homework is due, some days we'll have class, some days we won't. It doesn't matter. Even if homework is due on a day that we don't have class, it is your responsibility to get it to me before 3:10 that day, okay, if we don't have class. If we have class that day, it is due at the beginning of your class period. So if we have class on Monday, you're all going to walk in Monday and have your homework papers all stapled together. You're going to put them in the plate. If we don't have class on Monday, then sometime during the day, you are going to walk in and put your papers in that basket. If I am teaching, if I am the one teaching, I have absolutely no issue with you walking in, putting your homework in the thing and leaving. So during your resource period or on your way to something or whatever, you can drop it off before 3:10. Before 3:10. If I am not teaching, this room is used every period, so if I am not teaching, I don't want you interrupting another teacher's class. So right back there is my chair. Right there behind my desk is my chair. You lay your homework on my chair. All right? Got it? If I am not the one teaching. Okay? That. If you by chance have your homework done tomorrow, there's an early homework bonus for turning your homework in early. So if you have it done, you want to turn it in tomorrow, that's fine. You don't have to turn it in until Monday. I have certain things I'm looking for. So I will go through and make sure you've attempted every problem, and then I will look at certain problems in each assignment. I am not grading every single problem and all that. That would take me 15 years. But there are certain problems in each section that I'm zeroing in on.
So, if we do have a question, should we ask that?
Anytime in class, like right now. If you have a homework question, right now is the time to ask it.
I had one on.
Can you tell me what the problem is? So it's in P5 and it is number what?
29.
Okay, so this is P5 number 29. So we're going to review that real quick. It's good to go back. P5 is good. P5 number 29 says x squared plus x minus 1. Solve graphically. Solve graphically. This does not factor. Could we solve it if we didn't have a calculator? Would there be other ways to solve this? Sure, we could use the quadratic formula or even complete the square. But this one says solve graphically. So I'm not going to go through the steps. We already did this, and I told you I'm not repeating. So if I want to solve graphically, I'm going to go to y equals and put in my equation, right? If you have a calculator today and you haven't done this problem yet, you might want to work along with us to make sure you get the same answers. So I go to y equals and I type this in right here. Remember, if by chance your equation is not set equal to 0, that's the first thing you have to do. Get it set equal to 0. Then type in y equals And then I'm just gonna hit graph. Now, I don't know how your window is set from whatever problems you've been doing. Tell me, what do I need to see? Whatever this graph looks like, what do I need to see? Where will I get the answers to the problem?
The x-intercept.
The x-intercepts. So I need to see these 2 points. I don't necessarily need to see this one. I happen to with my window set up, but I don't need to. These are the 2 I absolutely have to see. If I don't see those, then I will change my window, making it bigger or smaller or shifting it left or right, whatever I need to do by changing x min, x max, y min, y max. Mine is perfect, and I have a standard window. So the standard window, remember, is -10 to 10 on your mins and your maxes. That's called the standard window.
What's
This is on P5?
Uh-huh.
for Y scale?
P5 number 29. Just leave it at y. There's no need for you to change
Oh, Y scale is
that.
supposed to be 1?
Yeah,
Okay.
there's no need to
Mine
change
was
it.
different.
Okay. Now, I'm only gonna find one of these because I find them both the same way. And we've already gone through this, we spent a whole class period on this, so I'm only gonna go through one of them. So I'm gonna find this one first, it doesn't matter. I'm just picking this one. So remember how we do that from our graph, we hit second calc, remember? And then what do we choose once we do second calc? 0. And then we set our cursor, so we splash in over here, hit enter. Set your cursor, so we splash in over here, hit enter. Set your cursor so it's close to the dot, and I got -1.618 as my x value. You would do exactly the same thing to get that one. That would be a different point, obviously, but you would do exactly the same thing to get that one. This is for it. Am I going to have to be able to do this on my test? Yes. We spent a whole day on it. Yes. You need to be able to. We may practice that in with our projectile motion, but before I erase all this and start in with that last problem there, in our notes, are there any other questions that you discovered from the homework? Yes.
P4 number 47.
Okay, now we're going to P4 number 47. Says we have a jet airplane climbing at takeoff with a slope of 3/8. So here's the jet airplane climbing at takeoff, and his rise over run is 3/8. The slope is 3/8. Rise over run. This is number 47 in P4. How far in the horizontal direction will the airplane fly to reach an altitude of 12,000 feet? P4 number 47. So all I know, here's my airplane flying up into the sky, and the slope of that line is 3/8. I want to know how far over does he have to go in order to get up 12,000. Any thoughts on that? I'll give you a hint. We're going to set up a proportion.
Hypotenuse. No.
Can you think of a proportion we might set up?
3/8, 12,000 over X.
Exactly, Brittany. Thank you. That's exactly right. Rise over run is 3/8. So y over x is 3/8. Y over x is also 12,000 over x. So I have a proportion. We've looked at these before in other problems. We'll cross multiply. And then divide. So if my arithmetic is right, I'm getting 32,000 feet. 32,000 feet.
Hey, Mrs. Stewart.
Yes.
So I didn't know you said no to pen. I read the syllabus. So is it okay that I just like rewrote these 5 problems for this one?
It's okay, if you accidentally did it in pen, go ahead and turn it in, but from now on, do everything in pencil, okay? Everything's in pencil.
Yep.
All right, one more homework question, we gotta get to our projectile motion.
P6, number 24.
P6, 24. So this is one of those that is super simple, but it looks so hard. This is a psych-out problem. They put these on the SAT sometimes. They're really simple, but they look hard. Because they fill them up with variables and stuff.
What number is it?
Number 24 in P6. All right, so I was talking, I think I got it copied right. Okay, we talked about these the other day. If you have an A plus BI equals X plus YI, the only way that can happen is if this equals this and this equals this. That's the only way this can happen. So notice you have a plain thing and an I thing on both sides of the equation. The plain things must be equal. So what's the plain thing on this side? X. What's the plain thing on that side? Now that would be no i's. What has no i's over there? 3 plus 4. So X has to be 7. Done. Now, the Y thing, or not Y thing, the I thing on this side has to match the I thing on this side. All right, so what's the I thing on this side? 6. What do I have over here? What's that? What's the I thing? Negative 1 minus 2y.
Yeah.
You have a negative 1 and a minus 2y.
So it's negative 7.
So 7 equals negative 2y and y equals negative 7/2. Yeah. So again, do not get scared by those. It's really simple. Everything without an I must be equal, and everything hooked to an I must be equal. All right, great questions. Keep a list with a few more tomorrow. If I don't get to all of them, you can always come see me during Flex, not tomorrow. Because or not today, but tomorrow you could come see me during Flex.
Do we have to go to
Oh
that
no,
county
not
fair?
tomorrow, because we have county tomorrow.
Do we have to go to that fair?
I think so.
The seniors don't have to.
I don't really
I'm
know.
already
You,
out there.
you should go
Already
just
in
to
30
support your
clubs.
freshman friends. All right, here we go. Yesterday, I had this formula on the board, and I said, this is the formula for projectile motion. And we went through each thing and talked about what everything meant in here. This is just your height. This, V sub naught, is your initial velocity, which I'm back in my notes, part 3, the one we started yesterday. That's an 18. And this is our initial height, which in this problem is 12.
Which one?
This is 3A, right where we left off yesterday. We didn't finish it. We got this set up.
Oh, yeah, we do.
We didn't finish it, so we're finishing it now. So I set it back up, plugging in the initial velocity and the initial height, which are there in the problem. They told me those numbers. So now I have this equation. And it says, when will the ball hit the ground?
We found out that height was 0.
That means this is 0. I don't know how to explain that, kids. If the ball is on the ground, its height is 0. I mean, I don't know how else to say it. I mean, that's just common sense. So my job is to figure out, okay, so here's the situation. We got this building, we have this ball thrown up, and we want to know, when does it hit the ground? Right?
Yep.
Now, what kind of an equation is this? What do we call an equation with a squared like that? Quadratic. Could I solve this using the quadratic formula?
Yeah.
Yes. Mr. Menser?
When we have like the variable t, are we allowed to change the variable?
You totally can, as long as you remember.
To put t in the answer.
Well, I don't even care about that, but remember that is the time. That x is going to be the time.
Okay.
So you will say, 20 seconds, or whatever. Yeah. Okay. Now, I'm going to use the quadratic formula on this, and I notice that everything in there is divisible by 4, or by 2. Do you notice that it's all divisible by 2?
Yep.
So I'm going to go ahead, and just to make my numbers a little bit smaller, I'm going to divide everything by -2. I don't know about you, but it always bothers me to have a negative out here in front, so I'm just going to divide everything by -2. Do I have to do that? Absolutely not. I'm just hoping it makes my arithmetic a little easier. So here we go, t or x, if you changed it to x. Yes, sir, what are you doing? You know what? If my observer, whoever observes me, would come in here and you had your head down, I would get in trouble. Okay. All right, so t equals -b plus or minus the square root of b squared minus 4 times a times c. Oh shoot, these numbers are still pretty big, aren't they? All right, let's get a calculator out and figure out what that is. I was hoping they'd be a little smaller. Did I make a mistake, or does that look right?
That's right.
If you don't divide it by 2, how is it going to be the same answer?
Because remember, it's a division, and so these numbers are going to be twice as big, and this is also going to be twice as big, so it's going to cancel out. I promise. I promise.
Because I did it without dividing by 2.
Well, okay, now this is going to look different, but ultimately it will give you the same decimal values. So 9 plus or minus the square root of 273. I got 273 under there.
Yeah.
Which is not anything.
That's it.
That's your answer?
No. I'm going to, since this is a word problem, I'm going to work it out decimally. So, because I said how many seconds or when does it land, nobody answers like that. I want to know, is it 3.5 seconds? That's what I want to know. So, 9 plus the square root of 273.
Wait, why was it positive 273?
Because these make it add, so it's 81 plus whatever that is times each other. And then I got to divide by 16. Did you get, as one of your answers, basically 1.6? Alright, so let's make sure everybody's typing that in right. There's 2 of them here, you can only do one at a time. So I did 9 plus the square root of 273 equals, and then divided by 16. So 9 plus the square root of 273 equals, and then divided by 16. And that should give you 1.6.
The other one's -0.47.
All right, Brittany did the other one, which is 9 minus the square root. You can't have negative times. So that one, what did you say it was?
Negative 0.47.
Negative 0.47. That one's extraneous. Now, I want to show you graphically, though, what happened. Remember, we threw this off the top of this building? If I continue this parabola, here's the origin right here. You see how you do get an x-intercept back here?
Yes.
but it doesn't make any sense in the problem because the ball started right here, right? But since we're graphing the whole shape, we would get one back here, it just wouldn't be counted. All right? Good job. Let me check my time. Anybody have any idea what time it is?
It's the lunch period. Yeah.
I think
Started
it's
at
a lunch
25.
period.
Is that 35? This whole period, yeah, the whole lunch period.
Okay, yeah, well, we still have a little bit of time. We're not quite ready yet. So let's go ahead and do the next part. When will the ball be 15 feet above the ground? Now, I want you to stop a minute and keep in mind that this is the equation we are using for every part of this problem. Okay, this is the equation we built for an initial velocity of 18 and an initial height of 12. So for part B, come back to this problem, this equation. Remember, you have two variables. You have a height variable and you have a time variable. The question says, when will it be 15 feet above the ground?
So you plug it into the height.
So you plug 15 in right here. So now we have the equation 15 equals this stuff. And we have to solve that one.
It's like a subtract it.
We're going to subtract the 15. Remember, you want 0. You want your equation to equal 0. So we're going to subtract 15. Is that everybody still with me? And now what are we going to do? We're going to do it all over again. The quadratic formula all over again.
Does it vacuum?
So, oh, I don't know. I don't think so. So here we go. Nothing divides out. It's just a mess. So here we go. T equals negative b plus or minus the square root of, I think it's 364, but 324.
This is such a sad equation.
Yes, 324 minus 4 times a times c. It's a good thing we're big kids, because this would be scary otherwise. Now underneath, I got 132.
Yup.
Now we're going to type this in. We're going to be really careful, because one of them is negative 18 plus the square root of 132 over negative 32. And one of them is negative 18 minus the square root of 132 over negative 32.
Can you plot a common factor?
I don't. We're typing them in on the calculator, so it does not even matter. We're typing it in. So it doesn't, you can if you want, but there's no need to. I do want to remind you though, when you type this in, it's negative 18 plus the square root of 132 equals, and then divided by negative 32. Did you get 0.203? And then negative 18 minus the square root of 132 equals, divided by negative 32. Did you get 0.92? All right, now I got two answers. Look at our picture here. Our picture is, here we are on top of the building. We throw the ball up and it comes crashing down to earth. The question was, when will it be 15 feet above the ground? Does it make sense that there would be two answers to this problem?
Well, if it goes over 15 and it comes back down.
Exactly. Let me put this on a grid here, and let's say here's 15. Remember, this was 12, right? So here's 15. Does it make sense that it's at 15 feet on the way up?
And all the way down.
And then it's at 15 feet on the way down. So here it is on the way up, and here it is on the way down. All right, last one, and then I'll let you go to lunch, and we'll come back and finish this last one after lunch. How high, this is our equation for this problem. How high is the ball after 1 second? Exactly, Derek, that's right.
Derek?
Every time, boys and girls, you got an equation that has 2 variables in it. Every question that's asked is going to give you a number, and you got to decide if you're going to put that number in for the height or for the time. Here we put it in for the height. When will it be 15 feet above the ground? That's the height. Now Derek says, put 1 in here, right? Because
it's the time.
that's the time. So H equals, I'm putting 1 in, so that'd be negative 16 plus 18 plus 12.
Same equation. Wait.
Work it out. There's no teeth anymore. I put 1s in. I put 1 in here. So what is that?
Oh, that's just 30.
14 minus 16.
Is that 14 feet?
Yep.
So how high is it after 1 second?
So both T's are time.
Yes, T is time.
Both, okay.
T is T. In any time, in any equation, any formula, one variable has the same meaning in the whole formula. All right, so does everybody see why we put the 15 here, but why we put the 1 in here? See the difference?
Yeah.
All right, when you come back from lunch, I'm gonna give you your time in a minute. So stay put. And I figure it out precisely.
Do we leave our stuff here?
Yep, I will lock up the room. If I leave, which I probably will to go get something to eat. All right, so we are gonna be back. We're gonna be back at 11:54. All right?
Hey, right on.
Oh wait, 44.
No.
No, 54.
54.
We'll be back at 11:54. She's writing it on her hand. She's not gonna be late. 11:54.